Hello, dear students. So, in the last lecture, we have seen the exercise 3.2 of your third chapter of class 12 NCERT maths, that is matrices. So, we have already seen what is matrix addition and what are the definitions of matrices and some properties of matrix addition, subtraction, and after that, we have also seen the multiplication of two matrices and their properties also. Okay. Apart from that, we have also seen some similar product of matrices and like other properties of matrices, types of matrices. So let's start our this lecture, and we have just seen till question number 13. So now we will proceed to for after that only. So we have to show that 5 minus 1, 6, 7, 2, 1, 3, 4 is not equal to. So this is like this property we have already covered, that AB is not equal to BA. Okay. So that we have to prove here. I hope that you can do this because you have to just multiply this side to this one and get the result, and then this to this, then this to this, and this to this. Okay. So you can find out the required result. After that, you have to multiply this to this, then add, and this to this, and add this to this, and add, and this to this, then add. Okay. So you will get the result that AB is not equal to BA here. Okay. So let's move forward and see the next question. That what is it? Just a second. I'm coming. Yes. So the second question is like similar to first one. That is 1, 2, 3. It is also like AB is not equal to BA. I hope that you can solve this question also. So let's move forward. Find a square minus 5a plus 6i if a is that. So here also you have to find a square matrix, then 5a, then 6i. So this is also like similar to you have done in the example part. So the calculation part is there, only that is lengthy. I hope that you can also solve this because you have to do just a square, then 5a, then 6i. So I will just tell you the hint of this. Just find out a square here. What will be that? 2, 0, 1, 2, 1, 3, 1, minus 1, 0. It is multiplied to itself. 2, 0, 1, 2, 1, 3, 1, minus 1, 0. Okay. So you have to multiply it to it. Okay. What is that? 2 into 2 plus 0 into 2. Okay. Plus 1 into 1. So just to calculate this, you will get the first row, first column element. Then 201 multiplied by this. So there is space which is lesser here. So I hope that you can do this because this is 3 cross 3 matrix. So there is a space issue for this. So you can find like similar to this other elements also. So yes. Let's move forward and see the next thing. Then you have to find 5a and minus them minus that with a square, and then 6i will be like 6 into identity matrix. Okay. Just substitute there all the values, you will get the result. Now 16th question is, if a is equal to this, then prove that a cube minus 6a square plus 7a plus 2i. So this is also similar to the question we have just seen in the exercise example part. Okay. You have to find the first a cube, then a square, then 7a, then 2i, and substitute all the terms here. Like just substitute a cube here, then 6a square, then 7a, then plus 2i, and you have to prove it equal to 0. Okay. So you will get the result. Okay. I hope that you can also solve this because due to space issue and time constraint, it will be not solved fully here. Okay. Let's move forward and see the 17th question. So it is saying that if A is equal to 3 minus 2, 4 minus 2, and I is equal to 1, 0, 0, 1, find K so that A square is equal to Ki minus 2I. So here also you have to find the Ka square, then Ka is equal minus 2I will be written in the next side and you will get the result. Okay. So I will just solve it for you, but it is also simple one. Find out here A square first. 3 minus 2, 4 minus 2 multiplied by 3 minus 2, 4 and minus 2. You get what? 3 into 3, okay, minus 2 into 4. Then minus 2 into 3, minus, sorry, 3 into, just a second. Yes. So here you will get 3 into minus 2 plus 2 into 2. Okay. And here you will get 4 into 3 minus 4 into 2. Also here 4 into minus 2 plus 2 into 2. So these are the elements. After calculating it, you will get here 9 minus 8, that is 1, minus 6 plus 4, minus 2. Here 12 minus 8. So it will be 5, no 4. And here minus 8 plus 4, minus 4. So that is your A square. Now A square is equal to Ka minus 2I. So write it like 1, 4 minus 2 minus 4 is equal to K into A is here only 3, 4 minus 2 and minus 2I is minus 2 into 1, 1, 0, 0. Just compare the left hand side elements to right hand side. So you will get what? Like 3K minus 2 is equal to 1. From here you can find out K, that is K is equal to 1 only. Okay. So K is coming out to be equal to 1. I hope you got this, that how we have calculated here K value. So you can verify it by other value. So if you calculate minus 2 is equal to, here minus 2K will come. So K is coming out to be equal to 1 only. So by second element comparison, you will get AK is equal to 1 only. So K is equal to 1 is the answer of this question. I hope you got this one. So let's move forward. 18th question is, if A is equal to 0 minus tan alpha by 2, tan alpha by 2, 0, and I is the identity matrix of order 2, show that I plus A is equal to I minus A into cos alpha minus sin alpha and cos alpha. Okay. So you just have to substitute the values here. I matrix will be what? 1, 1, 0, and 0. Okay. And I minus A will be like I used to substitute in the left hand side and I in the right hand side also. And then do the like matrix multiplication in the right hand side. And after that, you just compare the elements of left hand side to right hand side. You will get the result. Okay. Or you can just verify that I plus A is equal to I minus A into cos alpha, sin alpha, sin alpha, and cos alpha. So yes, let's move to the next question. A trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 505% interest per year, and the second bond pays 7% interest per year. Using multiplication, determine how to divide rupees 30,000 among the two types of bonds. Your trust fund must maintain obtain an annual total interest of rupees 1800 and rupees 2000. So this similar question we have done in the exercise, like example part. So you can see that lecture, and we will not waste here our time. Okay. So this 20th question is similar to the like 19th one. So you can see and find out the answer of this also. Okay. So here 21st question is the restriction on NK and P so that Py plus WY, we have the question as assume X, Y, Z, W and P are the matrices of order 2 into N, 3 cross K, 2 cross P, N cross 3 and P cross K respectively. Choose the correct answer in the exercise 21 and 22. Okay. So you have the restriction on NK and P so that the Py plus WY will be defined R. Okay. So what will the restriction on NK2? That the Py there, Py in the Py you should have the number of columns of P must be equal to number of rows of Y. It means that what are the number of columns of P? The number of columns of P are like K. Okay. And Y is having rows 3. So K must be equal to 3 here. So your first option is also saying that K is equal to 3 and K is 3 is showing in C option also. Okay. And WY will give the restriction as W has the order as N cross 3. So it means that P must be equal to what? Your that is P. So P must be equal to 3. Okay. So here no, P is equal to N only. Okay. So you will get what? Just a second. And here. Yes, K is equal to 3 only. From here also you are getting what? WY is there in the second term. So W has the number of columns as 3 and Y has the number of rows as 3. So this is already proved and this is equal here. So you don't have to do anything here. So option C will be correct here. That is P is arbitrary and K is equal to 3. Okay. So what is the correct option here? P option. I hope you got this part. If n is equal to P, then the order of matrix S is 7x minus 5z is. So if n is equal to P only, what is n here? N is the number of columns of X. Okay. So order of matrix 7x. 7x will give the order what? Your 2 cross n, and 5z will give what order? It will give you 2 cross P. Okay. So your n is equal to P only. So you will get the order of 7x minus 5z as your 2 cross n. So 2 cross n will be your correct for this. And also z, what is the order of z here? So z has the order as 2 cross p. So your 2 cross p is also correct here, but 2 cross p option is not given. So 2 cross n will be right here. So we will mark it only. B option is correct. Okay. So yeah, we have just completed our second exercise of this chapter. Now we will see the next topic of this. That is what? Transpose of a matrix. Okay. So let's begin this. In this section, we shall learn about transpose of a matrix and special types of matrices such as symmetric and skew symmetric matrices. Okay, so we will see one topic that is transpose of a matrix, and also we will see what are the special types of matrices such as symmetric and skew symmetric. So let's see the definition of your transpose of a matrix. If A is equal to Aij, B an M cross N matrix. Okay, Then the matrix obtained by interchanging the rows and columns of A is called the transpose of A. So if you interchange the order of your row to your column, it means that what are the elements in the row, you just change it into its column, exchange with column elements. So you will get what? Transpose of A. Transpose of the matrix A is denoted by A dash. Okay, A dash, like you denote by it what? If A is your matrix, original matrix, then A dash will be what? Transpose of a matrix. Okay, or you can represent it by A transpose also, AT. In other words, if A is equal to Aij M cross N, then A dash equal to Aji N cross M. So just you already have seen that in transpose we just interchange the rows element to column element. So Aij will turn out equal to Aji, and M cross N order will be changed to N cross M. For example, if you have A matrix and it is equal to 3 root 3 0 5 1 minus 1 by 5, order is 3 cross 2, then A dash will become what? This will come into it, like this column element will come into rows only, or your rows will come into column. So here you can see that 3 5 will come what? 3 5 was here your row element, so it will become in column. 3 5 will be written like this, then root 3, then 1, okay, then 0 and minus 1 by 5. So what will get the order here? 2 cross 3. Okay, because here you can see that two rows are there, 1, 2, and 3 columns are there, 1, 2, and 3. So that is why you just got this, that's why the order is changed here, because the elements are just exchanged here by like rows and columns. So let's move further and see what is the next thing. Properties of transpose of the matrices. So there are some properties also of transpose that is very important. So like you have to know these properties. We now state the following properties of transpose of matrices without proof. So we don't go through its proof, because that will take very much time, and also that is not in your syllabus. So these may be verified by taking suitable examples. So that will be verified only by taking some examples. First property is a dash is equal to A. So if you have like a transpose of A and you take the transpose again, it will come equal to A only. Okay. K into A bold dash is equal to K dash, where K is a constant. This is your second property. So if you have like K dash written like that, yeah, bold dash then equal to K A dash. Okay. A plus B bold dash equal to A dash plus B dash. A B dash equal to B dash A dash. So we will see that why these properties are true. If A is equal to 3 root 3 2 4 2 0 and B is equal to 2 minus 1 2 1 2 4, verify that A dash bold dash equal to A, and A plus B bold dash is equal to A dash plus B dash. KB dash is equal to K into B dash, where K is m constant. So we have to prove this property here. Let's see that how these are proved. We have A is equal to this, then A dash will be what? Just exchange of the elements in the rows and columns. So A double dash will become again equal to A, because first of all you have exchanged the rows elements to column, then again change its rows to column, so you will get only A matrix. Okay, you just do this, you will get the original matrix after two transposes. Similarly, if you take 3 transpose, you will get A dash, and 4 transpose, you will get again A. Okay, so this will like move on and go to cycle. Now this we have second property is proved here. If A is equal to 3 root 3 2 4 2 0, B is equal to 2 minus 1 2 and 1 2 4, then A plus B. A plus B we have found out. It is coming as 5 root 3 minus 1 4 and 5 4 4. Therefore, a plus b whole dash will be equal to what? Just take the transpose of this. It will become 5 root 3 minus 1 and 4 in the your column, and 5 4 4 in next column. Okay, like this. This will come. This will come like there. It will come here only, and this will come in the this column. So a plus b dash has come like this. Now a dash is what? You just take the transpose of a. So that is equal to 3 root 3 2 and 4 to 0. B dash is 2 minus 1 2 and 1 2 4. So a dash plus b dash is what? Just take the addition of these a dash and b dash. You will get 5 5 3 minus 1 4 4 and 4. So you can verify here that a plus b whole dash is coming out equal to a dash plus b dash only. Okay. So I hope that you also got these things very clearly. Let's move forward and see the next question property. So we have KB is equal to written like K into B matrix. So that will come 2K minus K, 2K, K, 2K and 4K. Okay. And then KB whole dash is K into 2 minus 1, 2, 1, 2, 4. That is equal to K into B dash. So KB whole dash is coming out equal to KB dash. This is also here proved only. Okay. So you can see the proofs here by taking suitable examples. Okay. So let's move forward and see what is the next thing. Now, if A is equal to minus 2, 4, 5, this is example 21. If A is equal to minus 2, 4, 5, B is equal to 1, 3, minus 6, verify that AB dash is equal to B dash, B dash. So here we can also verify this property by first multiplying A to B and then taking its transpose. And also we can take the A dash, B dash, like A dash we can find out, then B dash, and take the multiplication of B dash to A dash. We will get this result equal to AB dash only, AB whole dash. So it is clearly proved that AB whole dash is equal to B dash and A dash. Okay. Now, what is symmetric and skew symmetric matrices? So till now we have seen transpose of matrix. So what is actually the symmetric and skew symmetric matrix? So let's do this part and we will see the types of these matrices, that what are skew and skew symmetric matrices. Okay. So a square matrix definition is given here. A square matrix Aij is said to be symmetric if A dash is equal to A. If you have like A dash equal to A, that is Aij is equal to Aj for all possible values of Ai and J. So if you're like you take the transpose of matrix and it is coming out equal to the original matrix only, then your matrix is called what? Symmetric matrix. Okay. See here, this is very important that A dash is equal to A only. So if, for example, if you have a matrix have root 3, 2, 3, 2, minus 1.5, minus 1, 3, is a symmetric matrix that A dash equal to A. Just take here transpose, what you will get? Root 3, 2, 3. Then here you will get what? 2 minus 1.5 and minus 1. Then 3 minus 1 and 1. See here you can verify that this is just equal to this A dash. This A dash is equal to just A only. So A is equal to A dash is proved here. That is why it is this is a symmetric matrix. Definition 5, a square matrix Aij is said to be skew symmetric. So what is skew symmetric? If your A dash is coming out equal to minus A only. Okay, it means that your matrix is coming out equal to minus A. That is Aj is equal to Aij for all possible values of I and J. Now, if we put I is equal to J, we have Aij is equal to AI. If we put like I is equal to J here, so we will get what? Ai is equal to minus of Aii. Therefore, 2Ai I is equal to 0 or Aii is equal to 0 for all Ai's. It means that your diagonal elements should be equal to 0 here. You can verify that if I is equal to I, it means I is equal to j, this means that it is just talking about your diagonal elements. This means that all the diagonal elements of a skew symmetric matrix are 0. It is clearly written also here. Can check that this means that all the diagonal elements of a skew symmetric matrix are 0. So yeah, let's try to see the next thing. What is next part? So for example, here the matrix like D is equal to 0, E F minus E 0 G minus F minus G 0 is a skew symmetric matrix. Okay, this is a skew symmetric matrix because if you take the transpose here, just take the transpose, you will get what? B dash equal to 0. Okay, then E and F. Then here you will get minus E 0 and G. Here minus F minus G 0. You can observe here that it is coming equal to minus B only. Here, if you take the minus 1 common here, you will get what? It is minus 1 into 0 E F minus E 0 G and minus F minus G 0. Okay, and this is what? This is just equal to B. It is coming minus B only. So that is your example of what? Symmetric matrix. Let's move forward and see the theorem 1 of this. What is the theorem 1 saying here? For any square matrix A with real numbers entries, A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. So if you have any square matrix A with real numbers entries, like here all the entries as real numbers, so A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. You can verify this result. Okay. Let B is equal to A plus A dash, then B dash equal to what? A plus A dash whole dash. It is equal to A dash plus A dash dash, because your A dash plus A dash whole dash will be equal to what? A dash, okay, plus B. Here it was A, okay, not A dash. Here it was A, because B is equal to A plus A dash only. So your V dash will be equal to A plus A dash whole dash. So it will be equal to A dash plus your, yes, sorry, A dash whole dash. Okay, like A dash whole dash. Because A plus B dash is equal to what? A dash plus B dash. This property you have seen already. So it will come equal to what? A dash plus A dash. A dash plus A. Because A dash and whole dash is equal to A only. And it is coming out equal to B only. Okay. Why it is coming equal to B? Because A dash plus A is already, you assume that B. This you have already assumed as B. It is coming equal to B only. Therefore, B is equal to A plus A dash is a symmetric matrix. Because it is coming equal to B only, so it is a symmetric matrix. Now, similarly, you can prove that A minus A dash is a skew symmetric matrix. We just have to apply this property again and you will get the result. So, I hope that you can find out that property also and proof of that also. So, yeah, let's move forward and see that what is the next property or next theorem. Just a second, I will rub this. Theorem 2 says that any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. This is also very important property because if you have like A as a square matrix, and then we can write as A is equal to half into A plus A dash plus half into A minus A dash. Why? Because you just add them and then you will get the A element, A matrix only. Okay. And from this property, from this for theorem, we also know that A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric. So you are getting here what? Sum of matrix A as separate sum of symmetric and skew symmetric. This is symmetric. This is skew symmetric. So you are getting the sum A as summation of symmetric and skew symmetric. I hope that you got the properties which I told you today. Like all the properties are your important, and I also hope that you got whatever I taught today to you, like the examples and questions of exercise second, and after that we have seen some properties of like this symmetric and skew symmetric matrix. What are these type of matrices? And then we have talked about transpose of a matrix. So till now we have covered many things today, and due to some time foundations, we will just end up our lecture today at this point. If you have any type of doubt or any type of suggestion, you can tell us in the chat box. And if you have like if you want any private session or one-to-one session, then you can also tell us. So till now, thank you for today's lecture, and thank you and have a great day.